Here we have congruent shapes. Okay, and the first question you ask when you think of congruent shapes is what does a congruent shape actually mean? Okay, and this is an example in maths where this word is way more complicated than the actual definition. Okay, congruent shape simply means two shapes that are the same. Okay, they're the same shape. Okay, they might have been rotated a little bit. Okay, but the exact same shape. If you rotate them around, place them over each other, they overlap completely. They're the exact same shape. Okay, so you might think, oh great, why do I need to be here for a whole video, right? Because if it just means the same shape, that should be easy to spot, right? But no, not quite, okay? We need to be really confident in some of our rules here to spot when two shapes are equal. Okay, so let me go over the situations where we can know if two shapes are equal. Okay, and I like to kind of write out SSS, SSS, S, and then this little diagram. Okay, this will make more sense in a second, but this is the four rules that we need to know if two shapes are congruent. Okay, the first rule here, if all three sides are the same. Okay, so we've got two shapes and we know that they have these lengths. Well, if they've got the same length, they've got to be the same shape, right? That isn't rocket science. Okay, number two, if they've got a side angle side. Okay, so the key thing here is it's sandwiched. Like the letters here are sandwiched, we need to have our side to sandwich the same angle. Okay, and here we can see they're sandwiching the same 45 degrees, so these are the same two triangles. Okay, side, angle, side. Okay, and that might be a bit more complicated than it feels like. If we were to draw out this triangle with 45 degrees and 5, okay, it's basically saying there's only one way we complete this triangle, right? And the one way we complete it is by drawing this straight line from here to here. Okay, well this then has to have a side length, okay, of, let's say it has to be 3. Okay, now let's look at our other triangle. Okay, for 45 degrees. Yet again, there's only one way we can complete the bottom of this triangle, which is then also due to the same length, angle, it's also forced to be 3. So this is just side, side, side in itself again, and we know that if they share 3 sides, then they're the same shape. Okay, angle, angle side now. Alright, so angle, angle side is, let's say we have a shape where we know 2 of its angles, so we know an angle here, and let's say we know an angle here. Okay, so let's say this is 45 degrees, let's say this is 30 degrees. Okay, now what is this side that we need to know? Okay, well we need to know a side that is opposite one of these angles. So we need to know, let's say this side, because it's opposite one of the angles that we know. Okay, we need to know one of the sides that is opposite. Okay, because then yet again, okay, we have it forcing our third length. Okay, this is forced to be this long. Okay, it's forced to connect it here. Okay, so we're forced to know our distance here. Okay, and then we can, we know this is using 45 plus 30, 75 degrees, so this must be 105 degrees, and then we can use side angle side to then find this length, and then we've got side, side, side again. Okay, so everything goes back to side, 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 but these are just different situations that we might uncover. Okay, so angle, angle, side. Key thing here is this side that we know, okay, is opposite an angle that we know. Perfect. Now RHS. Okay, this is about a right angle triangle. Okay. And the rules about a right angle triangle is that if you know 2 of its lengths, then let's draw out our other shape. So we have our right angle triangle here. We've got 4, we've got 5. We just know 2 of the lengths that are the same. Okay, key thing here, we've got obviously our hypotenuse is the same. Okay, so right angle, we've got hypotenuse that's the same, and then we've got one of the sides which is the same. That means that these two triangles must be the same. Okay, and this isn't something you need to memorize, right? Because we know Pythagoras' theorem. We know that we can find out our last length. okay, which is going to be 3 centimeters here. So then this is supposed to be 3 centimeters here. So then we've got side, side, side again. Okay, so all these rules stem to the same thing. Okay, so now we've got a nice little proof of our circle theorem here. Okay, so prove this circle theorem. This is a circle theorem we should know that these two lengths are the same. Okay, this length and this length are the same. Alright, but how do we know that? We've just been told it's through a circle theorem, but we can prove this using what we've just learned. Okay, so one of the circle theorems we should know is that the radius of our circle meets the tangent at 90 degrees. Okay, the radius of our circle meets the tangent at 90 degrees. So meets at 90 degrees. Okay, so that's one rule that we have. Okay, we also know the radius, they're the same, right? So we label both of these R. Okay, so we know the meets at 90 degrees. We know both of these radiuses. Oftentimes in these congruent questions, label everything you know. Okay, everything you know. Okay, and as these are to do with triangles, well, let's make a triangle. Okay, this blue line is going to be equal, okay, because it's the same line. Alright, so we've ended up having our RHS rule, okay? We know that this is a right angle triangle, okay? We know the hypotenuse is the same length, okay? We know a side, which is the same, both of them are R, hence these two are congruent triangles, okay? Or we could just use Pythagoras' theorem to then find this length, which then has to be equal. Okay, so let's label this A, O, B, C. That then means that OAC and OOBC are congruent. Okay, congruent, remember, is just a fancy way for saying they are exactly the same. Okay, now let's look at some parallel lines. So if we had two parallel lines going straight up and then two parallel lines going straight across here. Okay, we need to show that if we draw a straight line between them that cuts these in half, that the two triangles that remains, let's label this A, B, C, D. So we need to show that ABD and DCB are congruent. Okay, we need to show that these are congruent triangles. Alright, well, let's, as we always do, label stuff that we know that's the same. Okay, so this line they share, so it has to be the same. Okay, now from this diagram you'd be tempted to say this is a right angle triangle, but I've said they're parallel. I've drawn them like this, but we don't know for certain that these two meet at 90 degrees. Okay, the next thing that we know for certain, okay, is we use some of our parallel line rules, right? So here, hopefully, we can spot a Z angle, okay, and from that Z angle, we've got that this angle and this angle are the same. So these two green angles are the same, okay. And then we've got another Z angle here, which forces these two angles to be the same. Okay, and then on top of all of this, we've got our rule that, you know, if we have this U inside, okay, our two parallel lines here, that then the green, okay, let's write this out, then the green plus our yellow plus our blue angle, let's label this our blue angle, must equal 180 degrees. Okay, why have I said that? Well, this could prove that these two blue angles must be the same. Okay, why must these two blue angles be the same? Okay, well, they need to be the same because what we have, let's write out our equation, we've got 180 degrees equals our blue plus our yellow plus our green. Okay, so in both these cases, we've got that our blue angle is 180, take away yellow, take away green. Okay, so it didn't matter what blue was, okay, they are both blue now, but both of them are equal to 180 take away our yellow angle, take away our green angle, okay, because we've got another U angle here. Alright, so let's remove all that noise and let's go back to the diagram that we have here. What do we know? Well, we know that this red line has to be the same. Okay, we know that this blue angles are the same, and we know that these angles here are the same. Okay, so the rule that we can use, there was many ways we could have done this. Okay, many ways we could have done this, but the rule we're using here is angle, angle, side. Okay, to prove that they're both congruent.